left behind, and a tidal tail where stuff is pulled towards the other galaxy. And so the whole galaxy becomes stretched. Again, it depends which way it's rotating compared to the directions of motion as to how far it unravels. And so the first indication you see of any merger, even when they haven't got that close to each other, is this material in the spiral arms gets distorted, gets pulled forward. You can see how this one is beginning to unravel. This one, you've got this large distortion on one of the spiral arms. So you start to get these very obvious asymmetries within the structure, even for the galaxies that got very close to each other. And then it just gets worse after that first encounter. And then, of course, the end products, as you saw in that simulation, they are really unlike the other galaxies. Here's an example of one that hasn't quite finished merging, and you can see it's just basically a scrambled mess. You've got the dust clouds. This probably was a couple of spiral galaxies. This is still going to take several tens, if not hundreds of millions of years to finally settle down into a coherent, very smooth, very organized galaxy. And so you get weird and wonderful end products from these mergers. So the way we study these is through simulations, because these galaxies are moving so slowly compared to human lifetimes, you can't see the changes in an interaction. All you have are the different snapshots. But we can model what happens in simulations and then compare it to the snapshots that we see around in space. And from these, I mean, the obvious parameters that you can see that are going to affect how badly one galaxy is affected by its interaction with another is due down to a number of factors, but the key ones to consider are obviously the types of galaxies involved. Spirals are very vulnerable. You've got those loose, fluffy, very extended disks of stars and gas that are very vulnerable to being torn off, much more so than the elliptical galaxies. In fact, you see nearly every simulation I show you today involves a spiral galaxy. That's because they're very good tracers of what's going on, because you've got those visible components that get sprayed out everywhere. If you merge an elliptical galaxy with an elliptical galaxy, you get an elliptical galaxy and nothing very exciting happens in the simulation. Spirals, you can trace what's happening to the matter much more clearly. And so, and spirals, as I say, they're much more vulnerable. You get these wonderful shapes that you will be seeing. Their relative masses. Obviously, you can see this from the Milky Way. The satellite galaxies are not affecting us very much. However, Andromeda is really going to mess us up. So again, a very equal match of galaxies affects both galaxies equally. A much different mass perhaps really disrupts one and leaves the other slightly disturbed. How fast they're moving towards each other is important. You can have two galaxies that get very close to each other and they're very equal mass, but they won't